read the objective to you, and then I'm going to give you a second, and you're going to think about what is different from yesterday's lesson to today's. Are you ready?
Yeah. Yes.
The objective for the lesson is solve division problems with remainders using the area model. Think about it. What's the difference? Don't say it. Think about it. What is the difference between yesterday and today? Raise your hand if you got an answer. Ready? Those of you who are checking out, think about it. What's the difference between today and yesterday? Ready? Go.
Yesterday we didn't have remainders.
All right, we don't have to speak in complete sentences when we answer like that, so just do remainders, right? Remainders is our difference, okay? We're adding remainders today. And not adding in the sense of like addition, but just we're working with remainders today, okay? And I promise it's just like yesterday, but just very slight thing added to it, okay? Can you wait a little bit, you guys, while we get people back? Okay. All right, we're not doing a sprint. We're gonna move forward. Okay. Okay, so you're not writing anything. Your whiteboards are closed, okay? You're looking up here. We're ready to learn, okay? So, as an intro problem, we have something pretty simple. So we have 37 divided by 2, okay? 37 divided by 2. So, so you don't have to write anything. You can just look up here. But Kendall, if you want to take notes, that's fine. Okay? So 37 divided by 2 is my problem. Now, I want you to look at 37. Think about it. Is that an odd or an even number? Think about it. Don't say it. Odd or even? Go. Odd. Can odd numbers be divided by 2?
No.
No. Okay. So right away we know we're going to have a remainder. Okay. So in order to show my work, I'll go ahead and do the standard algorithm. Okay. So 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. Bring down the 7. And we go back, right? Bring it on down, bring it on back. So 2 goes into 17 8 times. 2 times 8 is 16. 17 minus 16 is 1. So our answer is 18, remainder 1. Okay? Can we wait a little bit more while we get other people back?
Yeah.
Okay. We did that, yeah, but this is the intro. So as I just said, to show my work, I'm going to do the standard algorithm. But today we're solving with the area model. Okay? Daphne. Good question. So I realized I did this to the 4th grade class last year as well. It was totally my fault. It doesn't matter. However, I told you guys to use a lowercase r, but I actually prefer the uppercase because it's a little more clear to see. Sometimes the lowercase r can look like a weird number or something like that. So uppercase r is very like prominent, like remainder 1, right? So if you think about it, can you switch over to the uppercase r if you're doing a lowercase r? But really it doesn't matter.
Yes.
I just, when I'm looking at your papers, I like the big uppercase r. Okay?
So you don't make it.
Oh, no, did I call you? You gotta wait until I call on you, okay? I do have to move on, okay? Because that's not as important right now. We need to focus on the lesson, okay? So, I'm still using the area model, okay? So, with an area model, I need to draw a rectangle, okay? And my area of the whole figure, is 37, okay? Not necessarily this box right here, but this like figure that I'm going to draw, the whole thing is 37, okay? And as you may remember from working on grid paper and things like that, or working on a grid, when we show a remainder, we put a little box on the bottom, right? So what is our remainder for this problem?
1.
1. So there's our remainder, okay? So what I can do is look at my problem and say, okay, my remainder is taken care of. So it's donezo. It's out of there. It's right there. Right? 1. Then I take 1 away from my dividend. What's 37 minus 1?
36.
36. So that means this box right here is 36. Okay? Because what's 36 plus 1?
37.
37. Okay? The area has to equal my dividend. So the area is the whole thing, including the remainder. The area is the whole thing. So 36 and 1 equals 37. Okay? What am I dividing by? Go.
2.
2. So my width is 2. Okay? And then what times 2 equals 36? Think about it. It's in the problem. What times 2 equals 36? Go. 18. And that is it. Okay? So today I give you permission to do the standard algorithm first and then show the work in the area model. Okay? To show what it would look like, to represent it in the area model. Okay? Okay. Azul.
Is it kind of like the 2 lessons mixed together, the standard algorithm and the...
Pretty much, yeah. And then we throw in remainders.
Yeah.
Austin.
So just looking at the box, there's no standard algorithm.
Uh-huh.
If we were just to do the box and we didn't have standard algorithm,
Yeah.
how did you get the 8? Because 8 doesn't go into 6.
So we would have to do, you have to think of it as place value, right? So 2 would go into 30, or 20 would go into 30 one time. So then, right, if we think of like a place value chart, you just do a quick one, real fast, 10s, 1s. We have 36 divided by 2. I have to start with the tens place, right? How many groups of 2 can I circle in the tens place, Austin? 1. What does that 1 left over have to do?
Explode.
Austin, what is the 1? Yeah, it's got to move over. And how many does it explode into, Kendall? 10. So 1, 2, 3, 4, right? So that's what's going on with like this stuff. But that's why we did this first and then did standard algorithm, so you can kind of see what's going on. But you're right, 2 does not go into, like, you don't get 8 from going into 6, right? But it's really 16. So 16 divided by 2 is 8. That's kind of where we're going, okay? All right. So, yeah, so if you didn't have the standard algorithm, if you didn't do that first, okay, you would look at 37 and right away you should be like, oh, yeah, that's not divisible by 2. So I am going to have some sort of remainder. And the best thing to do with that, if it's like by 2, is to just take a remainder out already and then move on from there. And that's kind of what we did when I first started showing this, is show the remainder first to get it out of the way. So you take the remainder out, and your remainder will not always be 1, okay? So it's not foolproof. Yeah. I think today you'll just have like 1 and 2. I don't think you'll have anything too outrageous, but yeah. So your remainder will not always be 1. But for this problem, you can take the remainder out and then just focus on the rest of the problem after the remainder is taken care of, right? You can kind of think of like the remainder as this little bug that's just like get away. Like I don't, just get it out of there, and then you can focus on the bulk of the problem, okay? Nola.
So are we doing this for homework and not the one that we did on Monday?
Azul.
So technically, since we had a remainder of 1, we only took away 1 from the 37 and we put it in.
Yeah, because that's how much we would need to take away for this to be divided evenly.
Okay.
Okay, Logan, you may go to the bathroom. Nora, you may go to the bathroom. I don't remember who was after that, but we'll worry about that later. Okay? Kendall, go ahead.
So, on homework, can we do our standard algorithm thing?
Yeah, so as I said, I give you permission to do the standard algorithm first and then show it in the area model. Like, just represent it in the area model. So you don't have to solve with the area model today. You may solve with the standard algorithm and then show it in the area model, okay? So why don't you do this one with me on your whiteboard, okay? 76 divided by 3. We're going to do it together.
I forgot to write.
way that you can solve with the area model, okay? So basically I'm giving you 2 ways that you can solve your homework today, okay? So just write 76 divided by 3 kind of small on your whiteboard so you know what it is we're solving, okay? And then go ahead and draw your rectangle. See, and we're gonna kind of brainstorm together, okay? Because I'm kind of thinking on the fly right now a way to kind of describe this. So just be patient with me. If it ends up not working out, I apologize in advance, but I think it will work. So can you split 76 up into expanded form? So 1 box is 70, 1 box is 6. And give me just 1 second. 1 sec.
Is this a different way that we
1 sec. I said give me a second. Okay. Okay. Cool. Okay, good questions. You can raise your hand. So,
is this one of the other ways that we could
So one of the ways that you can solve your homework tonight was the first thing I showed you. This is another way.
Okay.
So whatever works best for you is what you're going to do tonight on your homework, okay? So we have 76 as our area for our figure, okay? What is our divisor? Go. 3. So label your width as 3. Close this real quick. Okay. So when we are thinking, and I'm not going to solve the standard algorithm right now. I'm going to use that to kind of check myself, okay? But when we are thinking of the standard algorithm, okay, and we're looking at our 7 tens, right? We're looking at how many times does 3 go into 7, right? That's like what we're asking ourselves. However, when we do this, we're actually looking at this 3 as a 30. It's 3 tens, okay? We match the divisor to the place value that we're working with, okay? So that 7 is not a 7, it's 7 what? Tens. So when we're dividing this, that 3 is not just a 3, it's 3 what? Tens. Okay? So did everybody get that part for right now?
Yes.
So we're going to use that to help us here. So this is 7 tens right here. So this 3 right now is what?
3 tens.
3 tens or 30s, right? So how many times, think about it, don't say it. How many times does 30 go into 70? Don't say it. Or how many groups of 30 can I make with 70? Okay, ready? Go. 2. Not 20. That's a lot. 20 groups of 30 is a lot. 2 groups of 30. Okay? 2 groups of 30. So that would be 2 groups of 30 would equal what?
60.
60, right? So you can write either 60 or 6 tens. All right? So if we're thinking of a place value chart, if I had 70 and I was dividing by 30, right? I could make 2 groups of 30, which is 6 tens. So here's 6 tens or 60, right? How many tens are left over? 1 10. 1 10. Okay? So that 110 has got to bounce over here, right? So what is 110 in standard form? 10. 110 in standard form is what? 10. So that 10 is moving over here, okay? if you want to think of it as like a place value chart, 110. So it's got to move over here. So how many does it explode into? 10. So we add that to our 6. So that 6 becomes what? 16. Okay. Lily, question?
So the 3 was our 30, and
Mm-hmm.
so then how did we get 60?
30 goes into 70 2 times, which is 60. So that's where we got 60. So basically you can think of it as like 60 tens we're taking care of, right? Like we almost like, so we circled those 2 groups of 30, which is 60. So that 60 is like put off to the side. And then whatever is left over is that 110 that comes over here. Okay? Austin?
So the way that I just thought about it was you're trying to clean up a mess.
Cool.
And you need
Yeah.
30 people to clean up 2 messes.
Cool.
So
Yeah.
you take 2 groups of 30 because you can't use 2 groups of 30 and 1 group of 10.
Yeah.
So that 10 moves over to the 6, group of 6, group of 16. So now the 16 can help out if they need help.
Cool.
They can
Yeah.
help by the 8s.
Yeah. I love it. That's awesome. That is really cool, Austin. Yeah, Avery.
Where do we get the 30? Because it's on 3.
So remember when we're looking, like you can use the standard algorithm to help you, right? So that 7 is 7 tens, right? So that 3 has to match the place value of the number that we're dividing. So we're dividing that 7, but that 7 is actually 7 tens or 70, right? So that 3 has to match that place value. Just like as if we were doing a place value chart, we're circling groups of 3, but it's in the tens place, right? So it's really 3 tens. Like we're circling groups of 3 tens. So I don't worry too much about that. Just know that that's not like 3 into 7. It's 30 into 70. Right? Even though we're dividing by 3, we have to match the place value that we're dividing. Okay? I know it's confusing. And maybe tomorrow I can show you guys like on the place value chart again how that connects. That might help. Okay? All right. So I think it would be helpful, but if you need to do the other way, that's fine. Okay? So anyway, let's finish the problem because it might make more sense once we finish it. Okay? So to review, we had 70 and 6 to equal 76. All right? So make sure you're not drawing or anything like that. You're paying attention to what's going on here. Okay? So that 3 that we're dividing by has to match the place value of the number that we're dividing, okay? So this 3 kind of almost magically, if you want, becomes 30.
Yeah.
So we have to think of how many groups of 30 we can make from 70. And we found out we can make 2 groups of 30, okay? So 30 goes into 70 2 times for 60, okay? Or 6 tens. So 6 tens compared to 7 tens, how many tens are left over? 1. That 110 has to move over to our ones place. Okay? So that's where 6 became 16. Now we divide 3 into 16 because now we're working with the ones place. So that 3 is actually 3 ones now, not 3 tens. It's 3 ones. So we have to think of how many groups of 3 ones we can make with 16. So think of your math facts, okay? Think to yourself, how many times 3 goes into 16? Don't say it. If you need to count up by 3s, you can. Okay, how many times does 3 go into 16? Go. 5 times. For what? For what? 15, right? 3 goes into 16 5 times for 15. Okay? So now we have 15. Okay? So by the way, I probably should have put this 30 goes into 72 times. And this 3 goes into 16 5 times. Okay? So then to 15 to 16, how much is left over?
1.
Oh, guys, 15 to 16. 1 is left over. Do I have any other place values after that?
No.
No. So my remainder is 1. Okay? So I know it's confusing. But remember this 2 is not 2, but it's 20. Okay? So 20 plus 5, which gives us 25. And then remainder 1.
Yeah, and I also did the standard also.
Cool. Yes, Adler.
Like, when you do from the area model, we still keep standard algorithms or linear because I think that
It might be easiest, but you have to know the why, right? Standard algorithm might be easy. You guys might have it down now, but you need to know why it makes sense, right? And this is what is contributing to that, right? But no, we are going to move on from this after today. So if this is confusing, that's okay. We will move on from it. But you need to know why the standard algorithm makes sense. So, good question. Azul.
could we go back to the other way we did it? I wanted to look at some things.
I actually want to do one more problem with y'all this way, and then I will go back to that, okay? Because we're not just going to be one and done. We're going to look at it together, okay? So, let's do 49 divided by 3. So we're going to do 5. Okay, 49 divided by 3. Okay, go ahead and erase.
You're doing it by yourself?
No, we're doing it together again. And we're going to do it the way that I just taught you, okay? And this thing that I'm writing over here, you do not have to put that down. I just want to show you something. But go ahead and split it up into 40 and 9. This is 49, so split it up into 40 and 9 in your area model. You do not need to put this place value chart down. I just want to do both at the same time to kind of show you. Okay? So I'm going to bounce back and forth between the area model and the place value chart to show you how they connect. Okay, so hopefully this strategy will make a little more sense. Okay? All right, class, we have 49 divided by 3. What is our divisor?
3.
3. Can you label your width as 3, por favor? Gracias. Okay. So in 49, I'm going to try and move a little faster, okay? In 49, I have 4 10s, 9 1s. Do you agree?
Yes.
Is that what's shown over here?
Yes.
Yeah. So as you guys know, I would look over here. I would look over here. Okay. 4 10s, 9 1s. I start with the left side, okay? I start with the place value that's furthest to the left, so that happens to be which place value? 10s. Okay? So when I'm dividing 4 10s by 3, I'm really finding out how many groups of 3 10s I can make with that 40. Okay? So I need to circle groups of 3. Okay? I can make one group of 3 in my 10s place. Okay? But really, that's one group of 30, right?
Yeah.
It's one group of 3 10s. Okay, is everybody catching my drift here?
Yes.
So that's why the 3 becomes 30, right? Magically becomes 30 because we're working with the tens place. So that 3 has to match what's going on here. So I was able to make one group of 3 10s. Okay, that's what's going on right there. Do you see that? One group of 3 10s, which is 30. Okay, so 30, you can think of it as 30 of like these little guys out of 40 are used up. Okay, so then I'm going to pause on that and I'm going to come over here. So that 3 has to match the place value of what we're working with, right? So that 3 becomes what? 30. So how many groups of 30 was I able, not groups, yeah. How many groups of 30 was I able to make with 40? 1. Okay? What is 30 times 1?
3.
Guys, anything times 1 equals itself. What's 30 times 1? 30. Come on, we reviewed this. You can do it, okay? 30. Or 3 10s.
Wait, hold on.
All right, so I'm going to review. So looking at the area model, I'm doing 40 divided by 3. But since I'm working with 4 10s, okay, I've got to work with 3 10s. So I was able to make one group of 3 10s with 4 10s, right? Because 40 is just 4 10s. So how many groups of 3 10s can I make with 4 10s?
3.
How many groups of 3 10s can I make with 4 10s? 1. Okay? So 30 goes into 40 one time. Okay? For 30. 30 goes into 40 one time for 30. So I have 3 10s that I've used up. That 3 10s is gone, right?
Right.
Bye-bye. How much is left over?
1.
1 what?
10.
1 10. So that 1 10 has to come over. Same thing over here. That 1 10 has to come over. So that 9 now adds 1 10 to it. What's 9 plus 1 10?
19.
19. So that 9 becomes 19. Same thing happens over here. I have 9 1s. That 1 10 comes over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now in my 1s place, I have 19. Okay? And then if I were to divide my 1s place, okay, let's do a different color. I need to circle groups of 3, right? So I'm circling groups of 3 10s. 1s, right? Because I'm working in my 1s place. So my divisor has to match what's going on with that place value.
Okay.
So that 3 is no longer a 30 because I'm working with the 1s place. It's now just 3. 3 1s, okay? So there's 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3, and then I've got 1 guy left over. Okay? So, over here, thinking of my math facts, 3 goes into 19 6 times. Okay? What is 3 times 6?
3 times 18.
18. Okay? How many 1s are left over from 18 to 19? 1. So my remainder is 1. Okay?
18 remains.
I would love it if you raise your hand. If you have a question, raise your hand. And I'm calling you. You have a question?
No, it's a comment.
Okay. All right, so my answer is the length, right? So my answer is 16, remainder 1.
Oh.
Okay.
That makes more sense. I'm a little confused.
I know. But you've got to think of the place values, okay? 49 is not just a 4 and a 9. It's 40 plus 9, right? So use that to help you out, okay? And this bears a passing resemblance to the standard algorithm anyway, right? 4, if I were to put this off to the side, okay? 3 goes into 4 one time, or 30 goes into 40 one time. 30 times 1 is 30, but we got to keep it with 1 digit, right?
Oh, it is.
Mm-hmm. So 1 is left over. It moves over to the 1s place, okay, to give me 19. 3 goes into 19 6 times. 3 times 6 is 18. 19 minus 18 is 1. So it's 16, remainder 1, right? They're very similar. They're very similar. We're just showing it with squares instead of like a little formula. Okay?
That makes more sense.
So yeah. Alright? So just do your best on it. If we come back tomorrow and you guys are like, ah, dang, I did not get it, that's okay. But I still need you to try it. Okay? I need you to try it. We don't just give up. Okay? Nola.
We have to try this math or come up to our record.
I want you to at least try this once.
Okay.
Okay?